Find dy over dx if x times e to the y equals y minus x. All right, this is another one that would be really difficult to solve for y in terms of x because we've got the e to the y and the regular y. So we're just going to use implicit differentiation here, and we're going to differentiate both sides with respect to x. Now on the left-hand side, we're going to have to use the product rule. I can already see. The right-hand side is going to be a lot simpler. Let's differentiate the left-hand side. We've got the derivative of the first factor. The derivative of x is just 1 times the second, e to the y. And then plus the derivative of the second times the first. Well, the derivative of e to the y is going to be e to the y, but then times what? Times y prime, because remember y is a function of x, so we're using the chain rule. The derivative of the inner function is y prime. So remember, it's the derivative of the first times the second plus the derivative of the second times the first. So we still need to multiply that by x. Don't forget, when we're dealing with the chain rule and the product rule, there's a lot going on and it's easy to get lost and forget something. Then on the right, the derivative of y is y prime minus the derivative of x is 1. So we've gone through and done our implicit differentiation. Now we need to get all of the terms with the y primes on the same side and all of the other terms on the other side. I'm going to do this one just a tiny bit differently. I'm going to move all the y primes to the right-hand side and the other terms to the left. And the reason I'm doing that is because if we moved all the y primes to the left, we would have 3 negative terms. This y prime would become negative. This positive term that doesn't have a y prime, when we move it to the right, would be negative. And this negative 1 is also negative. But if we instead move the y primes to the right, we're only going to have 1 negative term in the end. And it's a little bit nicer to have fewer negatives in our answer. So let's give this a try. If we move all the y primes to the right, then the y prime that's already there stays there. And then this other term with the y prime is going to become negative. So minus, I'm going to put the x out front, x e to the y, y prime. And then we've got this 1 times e to the y, which is going to stay where it is on the left. And then this negative 1, when we move it to the left, is going to turn into a positive 1. And you can see here we've got 3 positive terms, whereas if we had moved everything the other way, we would have had 3 negative terms. So I think this is a little bit nicer. Now we can factor out that y prime on the right. That leaves us with 1 minus x e to the y. On the left, we've got e to the y plus 1. And then to get y prime alone, we divide by everything in those parentheses. So we end up with e to the y plus 1 on the left, all over 1 minus x e to the y. And that is our final answer. If we had moved everything to the other side, it would have looked something like y prime equals negative e to the y minus 1 all over negative 1 plus x e to the y. Or maybe we would have had these in a different order. Order doesn't really matter here, but we would have had more negatives, and that's perfectly acceptable as an answer, but I like to think on the positive side. So I think it's nicer if we try to avoid having too many negatives when possible, because also students make mistakes when they're negatives. The students make more mistakes with negatives, so best to avoid that when it's easy to do so.